In today's video, I have brought you a very nice problem. So our goal, we are going to solve this following equation in real numbers. Okay, so we have the square root inside the square root and inside the square root. Okay, so we are going to keep the same number 1 1 1 with x here, so the whole thing equals to x. In order to find the solution for the equation, so we are going to find the same value of x here. It will be the same at the right hand side of it. It will be the same as the right hand side of this equation. Okay, so before we start working on this one, we are going to determine the domain range first, because we have a lot of restriction here. We cannot work like that. Okay, so now the first condition that we have, so we know that a square root is always positive or equal to 0. Okay, which means x must be a positive. Okay, so this is the first condition. So we know x must be super equal to 0. And the other thing, we know inside of this square root must be positive as well, which means we have also 1 minus x must be super equal to 0. Okay, so this is the most important thing that I'm going to concern about. So which means I get here 1 is super equal to x. Okay, so we know x is super equal to 0 and 1 is super equal to x. I'm going to summarize this one. By summarizing this one, I get 0 is inferior to x and x is inferior to 1. Okay, so we are not going to stop here, because we are going to check the extreme points 0 and 1 are satisfying this equation or no. So by plugging number 0 here, you get 0, you get 0 here, you get 1. Square root of 1 is 1, so which means 1 minus 1 is 0. I get 0 here. I get square of 1 minus 0, which is 1. Square root of 1 is 1. We found the left hand side of this equation equals 1 as you plug in x with 0. Okay, which means 0 is not satisfied this equation. Let's exclude 0 out of here. Let's check number 1. We get number 1 at the right hand side of this equation as you plug in x with number 1. Let's check the left hand side of the equation. You get here 1. 1 minus 1 is 0. Okay, we get 1 minus 0, which is 1. We get 1 minus 1, which is 0. Okay, so we get 0 up here at the left hand side of the equation. We get number 1 at the right hand side of this equation, which means x equals 1 is not satisfied this equation as well, which means we are going to exclude number 1 here. So which means we have x is living between 0 and 1, excluded number 1 and 2, and exclude number 0 and 1. Our solution inside of this one. It's so hard to calculate this equation like this. By squaring 1 time, 2 times, 3 times, you will have a huge number here. So we are going through a nice substitution here. Go through the substitution by setting square root of 1 minus x equals t. So let's set square root of 1 minus x equals t. Okay, so I will have a new expression of square root of 1 minus square root of 1 minus t. Okay, let's put x without replacing x at this time. Let's put another substitution. Let's put also 1 minus t equals z. Okay, now a new equation becomes 1 minus square root of 1 minus t becomes z here equals x. Okay, let's find the relationship between x and z by extracting t out of here and replace it in the first equation. So squaring both sides here, I get 1 minus t equals z square. Okay, by squaring this one and this one. So taking z square to the left and move over minus t to the right, I get 1 minus z square equals t. Okay, now we get t equals square root of 1 minus x, like this. Okay, also if you take a look at this equation, we get x here. Let's square this both sides to extract x. So by doing that, I get here 1 minus z squared, all is raised to number 2 as a power, equals 1 minus x. Okay, so which means x, by taking minus x to the left and move over this one to the right, I get x equals 1 minus z squared, all is raised to number 2 as a power. let's take this value of x, and insert it back into this one here. So this one is giving us 1 minus z square is raised to number 2 as a power. And also we are going to square both sides of this equation like this. By doing that, the radical will be cancelled out. I will be left with 1 minus z equals 1 minus z square, another square, all is raised to number 2. Okay, expand this one out, so I get 1 minus z equals 1 here, minus 2 times this one, minus 2, 1 minus z square, square again, plus this one quantity square. This becomes 1 minus z square, all is raised to number 4. Okay, so a nice thing here, we get number 1 will be cancelled out from the left and the right. Then I get minus z equals, before we expand this one out, because I don't want to have a long expression here, I'm going to take this term square, factor it out in order to simplify this expression easily. Okay, so I get 1 minus z square like this, factor, this one will be multiplied by 1 minus z square, this one will be multiplied by minus 2 here. Okay, now I'm going to expand this one out and expand this one out. So for this one I get 1 minus 2 times z square plus z to the 4th. For the next one I get here z to the 4th minus 2 times z square plus number 1 minus 2, which is minus number 1. So I'm going to leave this minus z as is it. I'm going to expand this one out. Now let's simplify this one more. So I will have a lot of cancellation here. So I get this z to the 4th cancelled out, one positive, the other one is negative. I get 2z square cancelled out also with this one. I'm going to put this one in increasing order. Let's start in with z to the 8. So I get z to the 8, following with z to the 6. I get minus 4 is multiplied by z to the 6 plus 4 times z to the 4. Moving over this minus z to the right, I get plus z minus number 1 equals 0. Okay, before we move on to the next step, I'm going to also remember here we get z equals to this one, which equals super equal to 0. We get also z is super equal to 0. Okay, as you know, z is dependent on x because we found a relationship between z and x. We found the relationship between z and x. We get 1 minus square root of 1 minus z equals x. Okay, so we already know x 0 and 1 are a solution. If we get x is strictly superior than 0, as we found here. Okay, so this one is telling us 1 minus z is strictly superior than 0. In the other word, 1 is strictly superior than z. Okay, then if we replace z with 0, let's take this one back here. Replacing z with 0 here, I get 1 minus z. I get 1 minus 0, square root of 1, which is 1, which means x equals 1. We know x equals 1 is not a solution as well, which means z must be strictly superior than 0. Okay, also z, it will be between 0 and 1 as x. Okay, so z and x are having the same condition. Okay, I'm going to take this expression at the top and continue solving our equation. Previously we're working on this equation and came up with this nice expression. So we have the equation of order 8, and also we have these two conditions which we are going to work on. We have x between 0 and 1 and z between 0 and 1, exclude number 0 and 1. So now we are ready to solve this equation. But the problem, we are going to solve the equation of order 8. Okay, it's more challenge to solve it like this. Okay, we are going to solve this one graphically. Okay, so before we start solving this equation, I'm going to remind you about a very important and useful tool which we can use here. So if you have a function, okay, then if you have whatever increasing or decreasing function, then the function is going to cross x axis at some point like this. Okay, so we get this point like x0, for example. This function is decreasing here and crossing x here at some point and keep going down. Okay, like this. If you take any input for this function and calculate output for this function here, you get, for example, x1, f of x1. This one is always positive because it is located above x. Okay, but this one here, if you choose in, let's take this interval, for example, 0 and a interval, for example. Okay, then you get this value of x1, x2. Then you get output of this input, which is f of x2. If you take a look at the output of this one is negative. So by the intermediate theorem, so we have f of x1, which we have here, is strictly superior than 0. Okay, then also we found f of x2 is strictly inferior than 0. Okay, there exists a point which is x0 belongs to this interval, open interval. Okay, which is, for example, 0, which we have here. Let's put it as a interval, EB. So open interval EB, such that f of x0 equals 0. Why is that? Because if you have 2 points, one output is positive here and the other output negative, which means the function is going to cross x anyway. Okay, at some point. That point is going to cross, the function is going to cross at the point, which is the image of this point equals 0. Okay, so that means the output of this one equals 0, which means f of x0 equals 0. So this is the theorem that I'm going to apply in order to solve our equation. Okay, so now let's move on to the solution. So the problem solving this equation of order 8 is not going to help us to solve it easily. We are going to calculate the first derivative function to see what is the sign, to find the critical point for that, just in order to check the sign of this function. How is sign, is it negative or positive? Then if we are not able to find the sign of this function, then we are going to move on to the second derivative function. So let's calculate the first derivative function of this one, f of prime z. Keep in mind, always we are working on this interval. Imagine if you have all the terms are positive. We are going straight to the solution. We are going to say the whole expression is positive. We don't need to calculate the first derivative function. We already know the sign of this one. Okay? But our problem, since we don't know the sign, since we have a minus sign here and minus sign here, we cannot say this function is positive. Okay, and keep in mind, and z lives between 0 and 1. If z is very small number, you will have a negative expression, because you will have a negative expression because this one is going to be smaller, and this one is smaller. This one minus 1, it will be take the whole thing. Okay, so which means the expression is become negative. But the problem, if z is approach to number 1, is living around number 1, this one is going to grow quickly up, it becomes more positive with this positive here. So which means the whole thing is going to be positive. We don't know what is the problem now. We don't know how to deal with that. We are going to simplify this error by calculating the first derivative function. So by doing that, I get here 8 z to the 7 minus 24 z to the 5th plus 16 z cubed plus number 1 here, okay, equals 0. So our goal, we are going to solve this equation. If I'm putting equals to 0 here, which means I'm going to calculate the critical points of this function. Even though with this one we still have a problem, okay, we cannot know the sign of this one because of this sign here, minus sign. We still need to derive this one more time. Let's move on to the second derivative function. So we get this one is multiplied by this one, which is 56 z to the 6 minus 5 is multiplied by 24, which is 120 minus 120 z to the 4th plus 48 z squared equals 0. Now the equation become more simple to work with, because we have z square, I'm going to take it as a common multiplier. And then also remember here we have a common factor for these three terms. I'm going to take 8 as a common factor as well here. So I'm taking 8 z squared factor. This one is given as 7 z to the 4th minus 15 here, z squared plus 6 equals 0. Now it's more simple here to calculate this one. Let's do a new substitution in order to transfer this one into the form quadratic binomial. Let's set z squared equals t. Okay, so we get f prime of z. This one it will have 8t factor. This one it will have 7t squared minus 15t plus 6 equals 0. Now it's more simple to find the roots for this one now. So you are going to use the delta as a discriminant. You will find t1 equals 0.22 and t2 equals 0.53. Taking these two values of t and replace them here and to find a new solution in terms of z. Okay, so we get z1, replacing this one by taking the square root of this one, you get plus or minus 1.14, or z2, the other one equals plus or minus 0.72. We are not going to take all these values because we are dealing with z must be lived between 0 and 1. So only the value we can take from here which belongs to our interval, which z equals 0.72. Okay, we are going to ignore all other solutions. Let's take this value of z and discuss the sign of second derivative function to see where we have a positive interval, where we have a negative interval. We're going through the variation table. Let's take the output of 0, but we are not going to replace it here. We are going to replace it in the previous one here. So I get number 1 here. Now let's check the sign of this one first and the sign of this one. This one becomes negative from here, below this point become positive from here. But remember you have number 1 also here. The one becomes negative here. So become plus, this plus with this negative become negative. Okay, so now we are going to check f prime of z. Okay, f prime of z is increasing here but is decreasing here. Okay, like this. Found output of this one, which is number 1. Okay, and then we found, let's calculate f of 1, replacing 1 here, I get 1 here. So again our function become decreasing again, but we have the same output here. If you check f prime of 0.72, you found 3.13. f prime of z is positive because we found the output here is positive here, is f prime of z is increasing on positive interval as well as negative interval. Okay, now we know the sign of prime of z, which is superior to 0. We know f prime of z is strictly superior than 0. Second, the variation table, we will have the same thing here. So this one we found is positive. We are going to keep the same point, 0.72. Since this is positive, that means the function is increasing. Let's calculate the output of 0 here. We get 0, 0, 0, 0, minus 1. Calculating the output of number 1, I get 1, so I get number 1 here. So this is the nice thing here, we get the extreme point, which is output of 0 equals minus 1. The other one is number 1, it's positive, which means by applying the intermediate theorem, the condition is satisfied, the intermediate theorem here. So we get here f of 0 equals minus number 1, which is strictly inferior than 0. Also we get f of 1 equals number 1, which is strictly superior than 0, which means there exists alpha between this interval 0 and 1, which we work on, okay, such that we have f of alpha equals 0. The alpha is a solution for this equation, okay? So, but we don't know which value of alpha is going to take. But this interval, we have a long distance between this point 0 and 1. So, we know the solution is always include between 0 and 1. We already know that by this assumption, okay? But we are not going to take this one as a solution. This one is giving us the idea the equation is accepting the solution, okay? Since we found this one. But there is a small interval belongs to this interval which we can work with to find exact solution for this one. It's not an exact solution, but it's going to be approach our solution, okay? So which appropriate points we can get here? So let's check the point. If you have point 6.1, this point 1.62, let's put 0.72 here, okay? Calculate this value of f of 0.61, you will find it negative, okay? Then also if you calculate this output of 0.62, you will find it positive. They are both very small numbers approaching 0, okay? But this one is negative, but this one is positive, which means our function is going to cross x-axis at some points between 0.61 and 0.62, which means there exists alpha belongs to this interval 0.61 and 0.62, but is not included 0.61 and 0.62, okay? That's the intermediate theorem rule, okay? Solution, which means f of alpha equals 0. Exactly, if you check it, you will find alpha equals 0.618, okay? Our solution here, f of alpha equals 0, okay? I mean alpha equals z0, okay? So we know we have a straight relationship between, we know z equals 1 minus x squared, because we already know replacing z with this value here 1.618, and then you get 1 minus 0.618 squared, you will have the same value, okay? So which means x is going to be 0.618, and also z is going to be 0.618. You can check it, you find the same thing here. So our solution for this equation between 1.61 and 1.62, okay? Like this. If you replace x with 1.618, okay, by guessing, because this value belongs to this interval. If we replace this 0.618 to x here, you will find the same thing here. You find 0.618 by calculator, okay? So I have done with this problem. If you have any question regarding this problem, just post it in the comment section below. If you have any suggestion, put it in the comment section below as well. So by the way, don't forget to hit the subscribe button and support the channel. And thank you for watching. I will see you next video. Bye.